Good morning, good afternoon, everyone. Thanks for joining the second session of our Open Science webinar series. This is a series called Open Science from the UNESCO Recommendation to the Reality in Asia and the Pacific. I'm Ferishte Rafiian, Science Program Specialist in UNESCO Regional Office in Jakarta, and I'm here with my colleagues Onchu Zheng and Kasumi Ochi, who are supporting organization of this webinar. Today, we are very honored to have four distinguished panelists with us. Mr. Kazuhiro Hayashi, who is the Director of Research Unit for Data Application in National Institute of Science and Technology Policy in Japan. Kazuhiro-san has been a researcher of open science and an advocate for open science since 1990s. He has experienced different open science practices, from scholarly publishing to open data, citizen science, and providing inputs to several global and regional open science policy development processes, including the UNESCO recommendation on open science during his career. We are very honored to have you with us, Kazuhiro-san. We also have Dr. Moumita Koley. She is a senior research analyst at Department of Science Technology, Center for Policy Research at Indian Institute of Science, Bangalore, India. She did his PhD in Vienna University of Technology in Austria in the field of organic chemistry. But after that, her interest evolved from the world of small molecules and cells to how science is structured itself and how it is, how science evaluation works. Now she has two hats as a senior research analyst at DOS Center for Policy Research in Bangalore and also a research fellow at Research Institute of the UK. Her work focuses on advancing the accessibility of scientific knowledge, fostering an efficient and responsible research ecosystem, and promoting research that responds to the local need. Moumita also serves as the steering committee for DORA and several other committees or communities for open science. We also have Dr. Juan with us, Associate Research Fellow in Chinese Academy of Science and Technology for Development in China. She has started her tenure position in CASTED in 2014. She has a master and PhD in economics, respectively from Zhonggang University of Economics and Law, and her PhD from BRIN University of China. She did a visiting scholar at Boston University. She was a clinical researcher at Schreiner Hospital for Children in Boston in the USA. And she has been also a research fellow at the World Intellectual Property Organization in Geneva, Switzerland. Her current role involves co-leading critical research initiatives aimed at strengthening China's SDI capacity and open cooperation through strategic policy development. And last but not least, we have Ms. Madiareni Sulaiman with us. She is a research data librarian at National Research and Innovation Agency, BRIN, in Indonesia. She has been an advocate for open science in the last years, and she has a strong interest in exploring how better research data management can benefit the SDI systems. This interest has driven her to pursue her PhD in information studies at University College London. Thank you very much for being with us. As we have realized that almost 80% of our participants, based on the registration forms, are new and you haven't participated in our first webinar. While I invite you to go back and review the recording of our webinar, the first session on our website, I would like to give a quick review to you that this project actually, this webinar actually is a part of a bigger broader project that we have designed in UNESCO Regional Office in Jakarta to assist implementing the UNESCO recommendation on open science through a project that is aiming at capacity building for open science in Asia Pacific, through advancing collaboration research for sustainable development. As you know, the UNESCO recommendation on open science was adopted in 2021, and it was supported by 193 member states of UNESCO. This recommendation aims to provide a standard framework, international framework for collaboration on open science. It provides a globally agreed definition of open science, which is defining open science as a collection of movements that facilitates collaboration throughout the whole process of science, from design, conduction of research, and also evaluation and sharing of the knowledge. It promotes sharing, reuse, and reproduction of science in different languages. And it's also aiming at opening the process of science beyond the scientific community, traditional scientific community, to the whole society. The recommendation definition of open science have different pillars, from open scientific knowledge, open access to scientific knowledge, which includes scientific publication, open research data, open educational resources, open source hardware or softwares, and also it includes open science infrastructures, both virtual or physical, basically the infrastructures, equipments, online platforms and repositories or archives that are needed for practice of open science among different stakeholders. It also talks about open engagement of societal actors, which means practices of participatory research, crowdfunding, that is opening the process and enabling contribution for everyone, and also open dialogue with other knowledge systems, including indigenous people. Beyond the definition, the recommendation also provides a set of shared values and principles for open science, for example, quality and integrity of science, which remains a common value, collective benefit of science for the society, equity and fairness for those who are interested in participating and having access to the result of science, independent from their background, their gender, their geographical background or financial background, and also diversity and inclusiveness, both in terms of people, but also methodologies and topics that we include in science. The recommendation also provides a set of actions for realizing open science, from promoting a common understanding of science to enabling a policy environment, investing in infrastructures and services for open science, investing in human resource, and building capacity and understanding of science, both for scientists and those who do planning and policy making for science, and fostering a culture of science through providing incentives, integrating open science principles in evaluation of science, promoting innovative approaches beyond, traditional publishing of papers, but also like peer reviews, publishing even negative results, and always exploring what are the impacts on different stakeholders, specifically the early career researchers. And then last but not least, promoting cooperation beyond the geographical borders, beyond the disciplinary borders. So this is a very brief overview of the recommendation. I apologize to those who have seen this several times. This specific project now is aiming at enabling collaborative research in our region. This is a need that we have distinguished through several discussions that we had, including the discussions we had during development of the recommendation. When we talk about collaboration, we are talking about collaboration between various scientific disciplines, between scientists from different countries, and between scientists and other societal actors. We have been thinking how to realize this. The first thing that our region and basically globally we need is to have an awareness of open science, what it is, what are different components of it, what are its potentials, especially for specific countries or regions, and what are the requirements and challenges. Then how to practice it requires technical skills, specifically for researchers on different aspects of open science. If as a researcher, I want to do open publishing, open access publishing, what are the requirements, what are the different systems Same with open data, engaging with societal actors and having dialogue with different knowledge systems. Then the last thing is to really do that and create good examples through conducting, co-designing research together, and especially in the fields that allows this multidisciplinary, multi-stakeholder work. That's why we have shaped this project with the support of government of Japan, found in trust that Japan provides for UNESCO activities. The first activity of this 3-year project is these monthly webinars that we have started last month in October, and we will continue by mid 2026, aiming to cover all the topics addressed in the UNESCO recommendation to make sure that we all have a good understanding of them. So the aims are firstly awareness raising on various aspects of open science, and the target is basically all the science stakeholders, from researchers, librarians, policymakers. We also want to showcase good practices across our region. We want to identify existing barriers, requirements, and opportunities for our region. And we also want to identify the current emerging actors and strengthen an inclusive open science community in our region. Then this follows with 2 other activities, which is development of a comprehensive open science course from 2026 to 2027. This course will be available both online, and we will also provide it as a pilot in 2 universities in the region in person, bringing together students and early career researchers from different countries, providing the technical knowledge they need to practice open science and the tools they can use. And then this will follow with a regional boot camp for early career researchers in 2027 and 2028 to enhance practical skills for co-design and implementation of collaborative, participatory, and multidisciplinary research projects focused on disaster risk reduction, which is a pressing issue for our region. And we hope to create several good examples through this and communicate the result of these researchers in different open ways. So with this, I would like to just reflect on who is with us today. Currently, we have 98 participants. Thank you so much for joining. As I mentioned, our sessions are also recorded. So if you miss any of the sessions, please feel free to review them later after the session. So today, from the registration forms, we know that we have a variety of people interested in open science, which is actually very homogeneously distributed this time. We have people who don't know much about open science. We have people who are aware of open science, but not involved in practices of open science. We have people who are practicing open science, and we have people like myself who are promoting open science. Then we have, in terms of stakeholders groups, we have 23% researchers and academics, 70% from lecturers of universities, students of universities, 17%. We also have people from international organizations and NGOs. We have people from private sector and industry. We have librarians and data managers, archive managers, and we have school teachers and many other people who have joined us. In the registration, again, we have all these countries, but not everyone joins. So also to track better which input during the session comes from which country, I would like to ask you, please, to scan this QR code or click on the link that my colleagues put in the chat to tell us which country you come from, and we can see the answers. So Kazumi-san, could you please show the answers now? Please scan the QR code and let us know. Okay, we have a lot of people from Indonesia, Malaysia, Australia, Japan, China, Singapore, Timor-Leste, Mongolia, Singapore, Japan, Myanmar, Mongolia, I said. So please put the name of your country in. We would like to ask several questions during this session, and it will very much help us if we know what issues, what challenges, what input comes from which country. We have Philippines, Afghanistan. Hi. Excellent. I see in the participants colleagues from many other countries, Iran, Sri Lanka, from our network. Okay, excellent. We maybe keep this a bit longer. I see 30%. So the link is in the chat. You can also scan the QR code. Our colleagues in Indonesia and Malaysia have done a very good job in spreading the word. Thank you so much. Excellent. So this is moving, but it's becoming static. So I hope everyone can access the slides. You can also go to the menti.com as it's indicated on top of the slide and use the code to access these questions. Okay, excellent. We have another question for you, and that is what aspects of open science are most relevant to you and your field of work? Can we go to the next slide, please? Okay, so please let us know what in open science is the most relevant to you. Statistics, public health, publications, archival science, statistics, public health, research papers, research itself, open data. Oh, health is becoming more and more. This is actually very relevant because this is actually one of the fields that every citizen is dealing with, independent of if they are a medical researcher, if they are a medical practitioner, or if they are just a normal citizen. Research dissemination, science diplomacy. This is a very fast emerging field, especially in our region. Open access, disaster data. We will come to that through this project. Data sharing, tech transfer, knowledge. Amazing. Very diverse, as you see, like citizen science, very diverse. We hope to cover all of this. Science communication, for sure, this is a skill that we see the need for that in our region. Excellent. Thank you so much. So the slides will be open during the next minutes while Kazuhiro-san presents. So please feel free to add more here. It will be very useful for us to see where we can focus more. So with this, I would like to invite Kazuhiro-san to please tell us a bit more about what you have experienced during this journey, which started by you recognizing, maybe we can stop sharing the slides, not to be distracted. For me, it's very interesting, your inputs. So Kazuhiro-san, you have had a long journey, which started from you recognizing that digital transformation is driving a major paradigm shift in science, beginning with science communication and now influencing different stages of research. Can you please tell us more about this shift and how you see this affecting the quality and integrity and impact of scientific research? Thank you.
Okay, anyway, so I'd like to, before answering the question, I'd like to show my journey from 1990s. So from digital please look at the orange part from digital transformation for journals with XML publishing by way of open access and sharing data. I'm now focusing on the openness of science, including the citizen science virtual society or digital decentralized science or something like that. So, and how can I say that? Yep, and I always use this slide. Once we, a human being, has experienced open science in the old age by way of the Gutenberg's mass printing, and it enhanced the Renaissance, and of course it's encouraged to develop or invent journal publishing and launching a round society. So now we are on the next generation of digital transformation of science and the society based on the internet. So from the Gutenberg world to the based on the web, internet, AI, data, or something like that, then that a scheme of society would be changed totally in the end. So that's my vision of open science itself. So open science is literally open science, but the meaning of open science is a kind of openness of the societal infrastructure to transform science and society. So, and let me show you the one of the champion case of the open science. Here's the data progress in cross-disciplinary research and create multiple impacts immediately. So in the COVID-19 era, there is a information professor, the professor of University of Tokyo, who his expertise is information. He handled WHO data with curiosity to find something different, something new. But he was not in the medicinal community, so that he published it on the preprint and disseminated with SNS. So that then immediately it came out the scientific impact. And also at the same time, it had a societal impact into the Yokohama city in Japan's one of the biggest city. And this is the kind of beauty of open science. We expected that with the reuse of data, researchers with an interest in data will be able to freely pursue their research across disciplines and discover a variety of value immediately. That was a kind of a perspective of open science. And in the COVID age, we had just one single use case, but here we now have a use case of this story. And this has two impacts. One is during this course, established publisher library or the research community didn't engage it. This is just a kind of a rapid and single pathway from one individual researcher to utilizing the open data to other societal impact. And the second impact is it consumed only half a year to have an impact. So very, very rapid societal impact with exploitation of the potential of open science. So based on this champion case, the style of research, style of publishing, and also a style of evaluation must be changed because this is not on the course of the current robust, established, but a kind of a legacy framework of ecosystem of our science. So that is one of the champion case. Another case is regarding a citizen science fund. The professor of Kyoto, one of the professors of Kyoto, Noto-san is my friend, and he utilized crowdfunding and citizen science. And this is a very funny story. He tried to get public funding, but he failed. So that he tried to get a budget from the crowdfunding. And his research purpose is also very affiliated with citizen science, because he tried to find a nuclear reaction in thunders, and no one knows where thunder happens. So that he collaborated with citizens to set sensors as many as possible to detect the thunder, and he finally got the evidence of the nuclear reaction in thunders, and that was published in Nature, and he got the public funding, and it was recognized as a physics world top 10 breakthrough in 2017. We have from the IOPP, British Physics Society. This is also the what we could not have we don't have the current established eco scheme of scholarly communication. So these kind of things include how to evaluate these kind of research activity with multidimensional. This sample has a very important scientific impact, but this has also the societal impact, educational impact, or any other dimensional aspect of the research. So how could we evaluate this? So we are still challenging how to measure these kind of things with altmetrics or any other indicators with data science. So this is a kind of a clear image of how open science will change the world, and where should we focus on for encourage to move forward. So that's my answer.
Thank you so much, Kazuhiro-san. Going from the public health, that we have a lot of interest in our audience, and how open data could be used to really make the research more efficient and also have a more direct impact on the society, and then how citizens could contribute in creating such great work. So we see that some of these changes, or most of these changes in the first view that we have for science and open science, are driven by external forces like digitalization, AI now, and COVID, for example. So from your perspective, what key missing elements should we still pay attention to? So it's not just driven by some external forces, but to ensure that open science transition does not further widen the knowledge and technology gap between the countries, and even within the countries, between different communities and different disciplines.
Okay, then I'd like to show you another story. Yep. Here is a kind of a cheat sheet of Japan's open science policy. I'm not going into detail. Please look at the blue part. Blue part is a policy for open science with data sharing. And the green part is open access policy. And it might be unique because Japan set an open science policy in 2021. And afterward, we set an open access mandate policy in 2024. Many countries is vice versa, is the opposite way. But anyway, we set some clear policy for research data sharing for open science, and open access immediate mandate policy for open science. And for open access we set several policy implementation to launch the new consortium for negotiation with commercial publishers to make subscription models towards the transformative agreement models to make it open access. And on the other hand, also we we have had a long history of the JStage. JStage is a governmental e-journal platform for open access. For Japanese learned societies. Now it has over 3,000 titles, 19% of journals are free to read, and most of readers and authors don't pay for reading EJ and publishing on EJ. So I always say that it seems that this is a big diamond OA journal platform, but I should say Diamond OA like journal platform because criteria is JST is not suitable for the criteria of Diamond OA journals. But anyway, we have an open access journal platform for Japan's Learned Society. And on the other hand, for research data sharing, we have had a policy to develop a research data platform called NIIRDC. Research data ecosystem development project has had more than 10 years. And we have some three approach for the management of the public funding research data from the institutional level with data policy and the policy enhancement to fund the big money for the research project with advanced research data management, such as the moonshot research and development project. And also, we of course focus on the disciplines. So we have some special programs for materials, biotechnology, disaster prevention for research data management. And all of them are supposed to be handled on the NII Research Data Cloud, eventually to have a kind of integrated scheme of the research data sharing platform. And here is a kind of open science platform in Japan. Regarding open access, JST has a JStage, JCAV, preprint server, and the JStage data is a kind of a data journal for the JStage. And as I introduced just before, we already developed the research data cloud with NI. But the point is, policy is ready, data infrastructure is being developed. However, science itself is an issue for research community primarily. We must not forget this. And the scientists have their custom space evaluation in the current ecosystem. So furthermore, I always claim that we need to pursue the hybrid strategic approach. One is keeping a stance that tend to maintain existing societal frameworks and games surrounding individual organization. It's for the short to mid-term. Let's say, when we try to implement OA, we should keep a peer review system with journal publishing ecosystem. And on the other hand, we also need to take a stance that actively pursues game-changing approaches, including exploring new organization models. It is for mid or long term for open science or research data management system. So that's a gap, and there are many missing pieces around there, I should say. And for this, Japan is trying to develop a research data ecosystem for promotion of data-driven science. It is a mixed project. And here is the NIRDC I just introduced before. It's an infrastructure with research data management tools and research data management functions. And this project is special for developing 4 teams to implement research data management, research data sharing, and open science. And one is platform alliance, and the second is collaboration integration to have use cases, and one is for developing rules and guidelines, and one is for the capacity buildings. And among those 4 teams are having a dialogue with this kind of infrastructure, somewhat with geeky people to develop something new service. And there has been a dialogues and trials to have use cases. So this is what is missing point and what Japan is trying to solve. So this is my second answer.
Thank you so much. You touched base on many of the requirements of open science, and it's great to see that Japan has done some preparation for many of these areas, from policy to infrastructures for, repositories for open access, for open data. One question that I have, so it's very much important to have this national investment in open science, but also if any of these infrastructures is open, really like open in terms of language, interoperability, you know, are any of these open to researchers of other countries in Japan currently?
Yep, it's very important and crucial point. So that, as I said before, open science, the word of open is literally open, but how can I say that? Free, open, totally free openness is just option of the open science paradigm. So, as I said before, so yeah, if we come into the open science paradigm, there will be still open strategy, closed strategy, or the secret strategy. It's a nature of the human being, or it's a nature of the human community. So we don't, and so what I would like to say is the order or the framework of those kind of open, closed, secret would be changed. So that as ever, each country had their own infrastructure, and even if we have open science infrastructure, with especially for research data sharing, there must be a kind of some various layer of openness, closeness, or secretness. So, and I should say it's a matter of the diplomatic, so that it's a matter of licenses between the countries. So, and that would be a dialogue and negotiation and diplomacy again. So, and mixing those kind of things. But in the context of UNESCO, we have to pursue the ideal aspect of human being, so that let's have an open mind to collaborate each other to make different or make something new. So that's my answer.
Thank you so much. Thank you. So our participants, please, if you have any questions for any of our speakers, put them in the chat. If you have any additional comment, please share them with us. This will be very useful for us. We always have a limited capacity to invite speakers, but through this process, we really would like to have inputs from your sides also. So I have now a question for our participants. Kazuhiro-san shared some good examples of open science practices impacting research and innovation. I would like to also hear from our participants if they know examples of open science impacting research and innovation in their field, in their country. This impact can be positive or negative. Please identify for us. If your answers are long, if you have links to share with us, please share them in the chat. Otherwise, we also have the Mentimeter slide that my colleague will share now. Does everyone see the slides from Kasumi with the QR code? Please scan the QR code and share your answers with us. And you have the link to the Mentimeter if needed in the chat. So the question is examples of open science practice impacting research and innovation in your field or country, positive or negative? Just want to make sure that everyone has access and they see the slides. Could you please confirm? because I don't see results coming in. Okay, so yes, so please share the examples with us through citizen science initiatives. It's positive. If you can also share any experience you have with this, if you are involved in any project or open science practice, please share the link or more information with us. We have asked this question last time, and we are going to compile all these good practices in our region, and we will share this document with everyone at the end of this series, and I'm sure it will have more use for us. Positive validity and transparency of research. Elsevier who want to change more than others in an attempt to keep their paywall content, which is higher than other publishers. True. How open science practices can impact post-conflict countries to heal and proceed in growing. This is very interesting. If you have examples of that, please share more details with us. You can share it now. You can share it via email later. This is a very interesting topic, especially when it comes to diplomacy. Rapid emergence of predatory journals. Yes, this is a negative impact. At UNESCO, we do have tools in the UNESCO Open Science Toolkit to identify these predatory journals. My colleagues have shared the link to the toolkit with you in the chat. Please check that document. This is a emerging issue that we need, at least as scientists, people need to be aware of that. Common public view of open science as a free, fully open access of all scientific process. Yes, true. It's not the reality. While we are promoting models like Diamond Open Access or participatory or crowdfunding exercises. Thanks for the link on RDC and free webinar, open access, open software. We are trying to democratize our archives, but we don't have a clear notion yet. Increased visibility and citations, lack of clear policies and guidelines. True. Thank you so much. Please keep sharing while you do this, and we collect it and we share it later with you. I would like to ask our next speaker, Dr. Moumita Koley, to please share with us what you think about when we talk about research quality and success. And then we want to, for example, talk about the impact of open science on this. What we are actually assessing when we talk about quality and success of research, and how do the current evaluation systems influence research culture and career progression? Please tell us also if there are any specific characteristics or challenges in the Asia-Pacific region. And in your view, what are the changes that we need to create a more effective and efficient research culture, and how open science principles can drive these changes? Moumita, thanks for joining us while you are traveling. I will share your slides and we are listening to you. I hope my slides are on.
First, I think it's still the Mentimeter, but yeah, it's come in, and yeah, my apologies because I'm traveling and you might hear some background noise. So yeah, from the beginning, I'm really sorry because it came up in such a time that I could not manage it to join from office. So again, I'm joining from phone, so the slides have been shared. But I hope that I would be able to make my point clear that what changes do we need to make in our research evaluation system so that we can take up the open science route. So the next slide, please. First has actually asked two questions, which has been combined. And what I wanted to highlight here is the journey as a researcher, the various steps we take in doing our research. That will lead me to the next step, that what exactly we are evaluating and what changes we can make in the system so that we are in a much better research culture. So if you see the slides, that what I had put is the research process that we go through, and I'm sure we have a lot of researcher here, and even who are into library professional and all would kind of understand what I'm talking about. That, yeah, when we start a research, we first design a research question. We have some question in our mind, but that question comes from a tremendous research, tremendous literature search, looking into the knowledge that already existing. And that's exactly where the first question of access to knowledge come, because this is one of the major recommendation in the UNESCO Open Science, that we need to have open access to all the existing literature. We know that we build from the existing knowledge. We know what Isaac Newton has said, that we are standing on the shoulder of the giants here, that is the previous knowledge. So definitely we need open access. Now next stage is, of course, we design and develop our research methodology, which also needs help of previous researcher. Then of course we perform our experiment, collect data. So here also various stages we can make things open, and then data analysis, and the final step, that is really one what I'm highlighting with all these text boxes, that once we do research, we have our results. Now we communicate our results in forms of publication. But this is where we don't share our data. The data is still under certain, as an maybe as a PDF format, hidden in the publication. So we can really improve there a lot. And of course, already the first step told about the open access. So we can make our whole publication open. And there also we need transparency of the whole process. Now, why I'm talking about all of this is because in our evaluation process, we are not valuing these each steps, how much more open we can be, how much more transparent we can be. These are not been rewarded yet. What we reward is the final step on publication. Only that particular thing, where do we publish. The next slide, please. Okay. See, this is what I was talking about, because the whole process, we never look into it. What we look into the final product, and how a individual researcher or university get evaluated. For example, it's actually based on the matrices. If you see that we don't look into anything else but the publication. So we go into the number of publication, be it university ranking, be it individual researcher. But now we have to ask ourselves this question, that the matrices that we have designed to evaluate ourselves or our institutions or university, are these good matrices? So for example, if you look into that for an individual researcher, we just look into the number of paper. Then now even we look into, of course, the journal impact factor. We don't look into the quality. Now is synonymous to which journal you have published, how much impact factor the journal has, and what is the journal quartile, even in some subjects. We also talk about a lot about H indices. And in our region, I'm sure people have now started to notice this, the top 2% researcher list, that's also getting valued. So it's clearly that we are valuing certain matrices, which are numbers, which are measurable, and we're very comfortable with that. But is it that a right way for us to go forward? Next slide, please. Okay, why I'm saying is these matrices are not good, and why it actually took us to this all the wrong routes and all the causes problem that we as a researcher we are facing. So let's take the first example, that is the university ranking. I'm just giving you only one example because to highlight my point. So for this one university, actually in a single year, it jumped from it was previous year it was 250 in the QS ranking, and it then jumped to 166. And it sounds very absurd that what that university could have done, that in a ranking parameter it has made such a huge jump. Fortunately, the university authority was sane enough to understand that they have not really done anything in extra, that they could make the jump, and they had investigated what made it, and they realized that actually it's practically by only one author, because in from the author of that university published a paper in Lancet, and this is a very multi-collaborative paper, and we know that such kind of paper gathers a lot of citation, and because of that, in one of the matrices in that ranking parameter, they scored such a huge scores that they made the jump. So this is obviously then tells you that how absurd this kind of matrices could be, why we should not use this to measure a performance of a university as well. University's performance should probably be measured again in a qualitative term based on their mission and vision. Okay, next slide, please. Again, it's again the reiteration of the same point that I have told, that again as a university, again it's we told about it, it's primarily the research paper. Now for individual researcher as well, no other contribution are being rewarded, it is only publication. And what the problem that has created is, I have put in the right hand side is in this orange thing, is that we have created a publish and or perish culture. We all now feel that pressure, and there is other conducts are happening, like data and image manipulation, because everybody wants to publish in high the they want to increase their number of publication, they want to increase is their journal citation, they want to increase their H index, and they have figured out that mm, as many as you can publish, you will improve this. And that obviously there was a highlight that there is negativity, the predatory publishing. So all are related to how we are evaluating research, what we are valuing in research. The next slide, please. Yeah. So because we were talking about our region in the Asia and Pacific, so I thought this will be a very interesting slide. It's a very recent and paper published in Nature, and it showed that researchers are facing the anxiety and depression more and more. If you see in the right hand slide, the bar graphs, the first one, you see that I have highlighted the Asia Pacific. In the Asia Pacific, you see that researchers are feeling the pressure even more and more. The pressure of the publisher Paris culture, they're facing it much more, even more than like 2-3 years ago. It was not much. It's now much more higher, which tells us that we are going in a direction which is really unsustainable, not just in terms of science, all the misconducts that we see, it's also in terms of the mental health of researcher. So we definitely need to make certain changes, and that's where open science comes in picture to make the system better. The next slide, please. Okay, this is one of the thing that tells us that why there is so much of problem our system. See, this is something I just put here to show that such an absurd papers can get published, so that our peer review system, which is backbone of science, is people are really becoming so careless that certain bad papers, it is just in one example, but last 2-3 years we have seen numerous such retractions where absurd papers have been published. So that's again, I'm highlighting that why we should change. Next slide, please. Okay, these are again certain examples of metrics manipulation. So, for example, there are huge amount of citation cartels are happening in my own country in India. To jump in the our own university ranking, there are certain misconducts happening. Then, if you see this citation cartel helps some mathematician. So, this paper highlights how in China and Saudi Arabia, certain citation cartels are being formed to improve the number of citation, and even in Google Scholar you can manipulate. So that clearly tells us that we need some alternative ways of evaluating research. We cannot go by number of papers and citation to evaluate research. We have to design an open science agenda for research evaluation as well, where we value research, open research data, and open access publication, obviously most probably in the diamond mode. The next one. Okay, this will be my final slide in terms of to highlight the problem and why in Asia specific we should be really cautious. Because again, this, I'm not telling that this research integrity index is absolutely all way correct or all. It is just an indication. And this was done by one professor, Lokman Meho, and this indicates that we have problem in our system. So for example, many of the universities in our region are high risk on the integrity meter. In my own country, in India, there are many universities that are in the risk region, whereas in Indonesia, for example, the top university in the index there are few universities in Indonesia which are really at the higher risk point, which tells us that we really in our region have to look into more in detail, because in our region are getting more vulnerable to certain practices because of this metric obsession. Now the last slide, please. Now, again, we don't have any magic bullet or anything to solve the problems. So we have to have collaboration. We have to together see how we can change our science system for betterment. I put this Dora and Quora, both are little bit on global north centering in a way. It comes from Europe, or one is more on US centric, and they calls for research assessment and or modifying the research assessment, taking responsible research assessment agenda. And in our region, we now have to, maybe UNESCO can help. We can start this dialogue and discussion where we can balance the quality and quantity, what tensions we are seeing now, how we can count diverse output, not only publication. Or an output does not mean only writing, it can be any other forms of communications, or forms of contribution to the society as a scientist. And we also have to avoid and reward the openness and transparency. That will only take us towards much better system. We cannot rely on these databases like WO, the Web of Science or Scopus, which are so close to evaluate our science. So we really need to rethink how we evaluate research, and we have to now collaboratively go towards a better system. Thank you.
Thank you so much. I just need to find. Thank you so much. It was very interesting. For me, it was even emotional. When you started to talk, before you even mentioned it, I was thinking about all the, pressure and mental burden I experienced, and I saw every PhD student around me experience, because especially in the fields that you need to engage with the societal actors, in the fields that you need to develop methodologies, there is this long process of years, sometimes decades, for getting to the results of a research project. And how can you capture this effort, and how can you even reward it in this current system? So thank you so much. And it's very interesting to see how this wrong criteria loop into each other and feed into each other. Like, we use the impact factor, and then it comes to university ranking, it shows itself. So it's a broken system feeding itself, and we really need to do something about that. This topic of evaluation came up also last time, and it will come up next time. We were initially thinking to have one session for that, but it's so embedded in the dialogue about open science that we will address it through many sessions of these webinars. And I hope we can come up with some regional initiatives for this. Thank you so much, Moumita. With this, I would like to ask our participants, in their experience, what positive or negative impacts do current research assessment metrics have? For example, which aspects support research performance and motivation, and which aspects create challenges or unintended pressure? So please share your experience on the impact of the current assessment system on your work. Kasumi-san, would you please share yes, so please, again, it's the same QR code. If you are already on Mentimeter, you will see the next question. Otherwise, please share the code and share your experience of the impacts of the current research assessment metrics with us. And there is a link in the chat. Negative is focus on quantity over quality of publication. Negative and minimal incentives, I suppose, for practicing open. Any other inputs? Performance-based, but not value-based. Minimum respondent. This is not very clear to me. If you can explain it a bit more. So we have the issue of quantity over quality. We have the issue of incentives. We have the issue of not being value-based. NHMRC in Australia asks for the top 10 publications in the last 10 years to avoid the counting of publications. This is a very great approach, which is still focused on publishing, I should say. Focus on quantity over quality. Yeah. And this is also something that it's easier to measure. And in the next session, we talk about this issue that we measure things that are measurable and we use them in the assessment system. So, Kasumi-san, could you move? Yeah. Short-term projects are assessed. Okay, it's moving, it's filling very fast. Narrow view that does not recognize work with students, nor work such as report, as opposed to published articles, exactly. Most researchers look for a journal with higher impact factor. This is a challenge in taking our journals forward and attracting good researchers. Negative is encourages quantity over quality again. Number, quantity over quality. Impact of research and assessing skills. Yeah. Focus on citation. Okay, great. So please keep adding to this and we keep the slides open. Again, we will share this later with you. With this, I would like to invite our next speaker, Dr. Juan Young, who has been working a lot on open innovation and open science performance in different countries. Kasumi-san, you can stop sharing. So yes. So Dr. Juan, could you please make it full screen? Yes, so I was just saying that, Dr. Juan, you have worked a lot on open innovation and open science performance in different countries. How do you see open science improving innovation ecosystem? And also I have another question for you. How can open science principles such as openness, collaboration, data sharing be integrated into national innovation systems to enhance both scientific excellence and impact? And what key policy or structural changes are needed? Thank you.
Thank you. Can you hear me?
Yes, very well.
Yes, it's great. Thank you. It's my honor to give a presentation on this event, open innovation and open science. First, I would like to give some background introduction to answer your question, and I will answer question 1 and question 2 in the following parts of my presentation, and also give some comments on the connect data on open science. Actually, that in China we have very two important policy documents about open innovation. The first one is released on 2019. Actually, it's a policy document on open innovation and how to strengthen China's open innovation capacity. And the second one is and the second one is released on 2000 last year, and this is open. It's also on open innovation, but it's focused on open innovation ecosystem with global competitive. To support this government's work, we developed two kind of open innovation index. The first one is the International Open Innovation Index. The second one is the Open Innovation Ecosystem Index. As you know that in academia, most of open innovation research is focused on firm level or individual level. It's seldom to find some research on national level. So we, based on the previous research, we established our conception on open innovation and open innovation ecosystem and the national level. And that's the background of our work on open innovation. And this is example of one of the results. Actually, I want to emphasize that all the work is it's to support government's police making formula the two important police documents. And that's the background. And in this session, I will focus on open innovation and open science and their relationship. Actually, in the perspective of China, of our research, the open science actually through its core practice, like open data, open source, open code, it provides a fertile soil and rich nutrients for its ecosystem. And for open innovation, it's act like a gardener or chef. That is like the for actually words, it's like our enterprise, that who will use this nutrition. I mean, use this things to calculate the products, to create services and business model that meets the demands of our market. And how these things works, I think I will answer the first question, that is from science, from how to move from open science to open innovation, that we need to promote open science, that it's not only just a self-renewable of this scientific communication. They also need to build some kind of crucial information superway for the national and even global innovation system. And then if it continues and effectively nutrition and drive open innovation, ultimately it will achieve a win-win situation for both scientific progress and socio-economic development. How it works, I think there are 5 ways to for this system to works. That is in knowledge flow, in participation and entities, in innovation cost, in adaptation speed, and last one is in sustainability. For example, in knowledge flow, if we want to move from open innovation to open science to open innovation, we need the knowledge flow can shift from restrict snow dimension to real-time open sharing. And for the in participation entities, it involves from limited institutional involved to dynamic collaboration among diverse actors, including the SME and citizen scientists. And it also dramatically reduce expenses through reusable open resources. I think that's how these things works. And I can also want to answer your question too. That is how the open science principle or practice being integrated in national innovation, especially for open innovation ecosystem. For example, I just give some examples. We can leverage the principle of openness and the data sharing. We can establish national open data infrastructure through mentoring open data policy and decided funding to enhance research efficiency. And for some, for the principle of collaboration, we should focus the cross-section innovation network by implement research evaluation reform that recognize connective contribution. In this slide, I would like to emphasize that is for the perspective of open science, you can see the practice in the national level. It's scanned. You can find that this police is not in one minister or in one department. We can find this in scattered police and the strategy in different in various national departments. And take China for example. In our framework, that there are at least 4 ways to integrate open science principle practice into its broader open innovation strategies. The first one is building a top-level policy system, develop open research infrastructure, fostering an open source innovation ecosystem, and engaging global open governments. For Switzerland, we can see the same situation. That is, we cannot see just only one policy or one strategy on open science. You can see lots of policy and strategy on open innovation scattered in different parts or different department or minister. So I would like to, so what can we learn from that is for the perspective of open science, and especially for UNESCO, you would like to integrate the principle and the practice into the framework of different country, but and the perspective of country, especially for China, we have our own policy and the strategy framework that you can see the open science and open science principle and practice scattered in different ministers, such as like Minister of Science Technology, Minister of Intellectual Property, and also Minister of Education. So we can find just one single policy or strategy policy documents on open innovation. I think that's. I just want to answer the last question about connect the data on open science. I think for this question, we need to know what kind of data we need to connect it, and the method. The second is the method to connect the data, and for the dimension, I have 4 recommendations. That is scientific publication. The second one is research data and code. The third and fourth one is research infrastructure and cooperation, research assessment and the impact. For the methodology, I think we need to use all the things that we can have, because we have existing database. We have some, we can conduct a specialized survey and questionnaire interview. We can promote self-reporting and data integration by institution, just like you are UNESCO, you are international organization, you can do that. And the last one is apply technical tools and text mining to get lots of information. I think OECD just launched a very interesting database that is based on the test mining. And my suggestion is do some international cooperation. As the experience I know that Global Innovation Index, it's published by World Intellectual Property Organization. They have connected and lots of data from international, very authoritatively international organization, just like IMF, OECD, Scoper, and Clarence, and other institution. But it also cooperated with other with other research institution or corporation or small firm to get data. They did a lot of international cooperation to connect the data and also work with different countries to ask them to self-reporting data. And I think that's the way I can suggest for the data connection for open science. I think that's all I want to present and answer your question one and question two. Thanks for this opportunity, and I would like to learn from you.
Thank you so much, Juan. It was very interesting. It was very comprehensive. And your point about diversity of how to approach true policy in different countries is very valid, especially for a region like us, where we have very diverse STI ecosystems, STI governance systems. So beside this open science here at UNESCO Jakarta and through our network of STEPAN, we are also trying to map better this diversity, because we really need to understand how the STI system functions and what's the structure in every country and where you can put open science. Your point about having different ministries engaged in this is also very interesting. Like, it's traditionally we think it's one ministry, but when we talk about interdisciplinary work and collaboration and multi-level work, it's super important to have different sectors of the government engaged in this. Thank you so much. We have one short question for our audience, and that is, based on your experience in your country or your field, do you see the open science movement more as a global policy agenda, more as a national policy agenda, or you see that as a cultural change happening in the science system, or several of these together? You can choose more than one option, but we would like to capture a bit more in our region and in different countries how you see this. As we are 5 minutes late, I would like to, while you answer this question, I would like to invite our next speaker, Ms. Madiareni Sulaiman from BRIN and from UCL, to please tell us about your work as a data librarian in the National Research and Innovation Agency, and how this has led you to your current PhD studies in the field of data management and also as an open science advocate. So my questions for you are, what are the key gaps that you have observed in research data management and data sharing in your country and in the global research system that motivated you to do this research? And how can open science fill these gaps? So this is how we start. And then I will have another follow-up question for you. Thanks.
Okay, thank you. So should I start now, Ferry?
Yes, please.
Okay, thank you. Good morning, everyone. My name is Madiareni Sulaiman, and you can call me Reni. First of all, thank you to the UNESCO for inviting me to join the discussion today, and I'm glad to be in the same panel with other amazing speakers like Moumita, Kaz, and Yang. It's an honor, and also see some familiar names or colleagues here in the participant list. So thank you for joining. I hope I'm not keeping you from your lunchtime. And well, I'm here to share observation from my work and from my engagement with global open science communities. But for the context, a little about me, I call myself my own data champion because I wear 3 hats. I'm a data librarian, an open science advocate, and a researcher pursuing a doctoral degree in RDM and open science. Therefore, I try my best to embed good RDM and open science practice in my own work. And to answer your question, Ferry, and also to understand the gaps, let me start with a paradox in Indonesia's research ecosystem that many of you in Asia Pacific may know as well. So Indonesia is recognized globally as the first or second largest producer of open access journals according to DOIJ, and we have over 5 to 7K active ISSN titles annually, the highest in the world actually, and more than 320K researchers are registered on SINTA, our national research index. Yet, if you look at research data, the underlying evidence that produced those journals and those publications, the picture changes dramatically. Our National Data Repository, BRIN Dataverse, which was established in 2017, currently holds only 4K dataset across the entire country, but the data deposit, it could be around like 10 times of it, like 40,000 that is in class access. So the question is, where is all the data? We publish a lot, but we preserve and share very little of the research data behind those publications. So this gap between publication output and data availability is what motivated my active advocacy in open science and also my doctoral research. And this visual might give you better understanding. The effort of building infrastructure is already there, but still there are gaps in questions. In parallel with the policy, human, and technological resources that are also need special attention. And it's added with the complexity of data policy across the borders. It depends on where we come from, where we affiliated with, and do we get support or not. So different contexts, different gaps. Just like how these personas here try to show you that data management can be done well or not if you are under established framework and if the ecosystem is there. So by meeting many data professionals and attending events related to data and open science, I've identified 3 interconnected gaps. So the first gap is the awareness and practice gap. We have policy that mandates data deposits. We have infrastructures. In Indonesia, like Korean Dataverse, our national data repository, ELSA, e-Layanan Science, or e-scientific service that facilitate to provide lab and infrastructure access for general public, but awareness among researchers is patchy. And I've met brilliant scientists who've never heard of FAIR principles. Many don't know that BRIN Dataverse exists beyond their institutions, and the word data management to many researchers mean folder organization on my computer. And the second gap, the life cycle gap. So there's no continuous support access across the research journey. During planning, only few researchers have seen a DMP template, like data management template. During collections, field researchers rely on handwritten notebooks or siloed lab system. And during analysis, code is rarely documented or shared. During preservation, we see ad hoc solutions like external hard drives, USB sticks, sometimes lost when someone leaves the lab. And data sharing, it's the last priority. The third gap, the interprofessional gap, this is what I focus on in my research. And what surprised me the most, that researchers don't know who to ask for help. Data librarian exists, data stewards and other terms in mostly in EU or global, but many researchers don't know that. And there's no visible bridge connecting researchers to these research supporting roles, so it's fragmented. So open science principles directly address these gaps, not with new infrastructure necessarily, but with a cultural shift toward integration and collaboration. So let me share quick examples from communities I've engaged with, like RDA, IVLA, CODIDA, WDS. For the awareness gap, some developed countries with mature data management policy have integrated data management and open science training into researchers' onboarding. So every PhD student gets basic training on FAIR and CARE principles and their repository options. The result, they get higher adoption naturally. And for the life cycle gap, the RDA Research Data Alliance has developed the DMP Common Standard, a simple template that guides researchers from project inception through preservation. And many data and open science communities and events that I attended, they regularly showcase examples where data management is embedded in every funding applications, every ethics review, every publication workflow. So other initiatives that you could look further into that have been mentioned many times by Moumita, Kaz, and John Young. It can be like Quora, Dora, on reforming research assessment, make data count, open science monitoring initiatives, EOS, and many others. And for the interprofessional gap, like Codata and WDS emphasize that data management is a team sport. It is part of team science. And for data deposit sharing or availability statement, in this case, my role and other research supporting staff, like data librarians, can work alongside research administrator, IT professionals, and journal editors. I've seen this in many regions like US, EU, and increasingly in Asia at institutions like in Singapore, Malaysia. And in Indonesia specifically, BRIN's Directorate Repository Multimedia and Scientific Publishing is positioned perfectly to orchestrate this, but it still needs formal recognition and resourcing. For instance, like data librarian roles. And we do have credit, contributorial taxonomy that should embed in every aspect of recognizing all research contributors. And the way we can see it is from PID graph as one of the many solutions when people, their works, their affiliation are interoperable and connected. So here's the hopeful part that Indonesia, like many other Asia Pacific region, already has we already have the building blocks. We have policy. Also, we do have UNESCO Open Science recommendations. We have infrastructures. We have commitment from our leaders who see that this is important. And in Indonesia, for instance, One Data Indonesia a case as part of open data government or the Hari Layar research funding support. So when some other researchers will sail using research vessels for 3 months gathering the data, they are mandated to have a data management plan and a data deposit as well. RGA, Relawan Journal Indonesia, it is the Indonesian grassroots community for journal management and open access network. They have amazing volunteer energy to support open access. So what we need is systemic connection, linking these pieces together through trained actors, integrated workflows, and explicit career pathways. So when open science principles guide these integrations, we shift from that this is extra task to that data management is how we do science. And that's the potential I see for our regions. So yeah, thank you, Ferry.
So much. Thank you so much, Reni. Very interesting, opening our eyes to all the work that is needed to be done to support scientists to practice open science or at least open data. So I would also like to, we are very happy to have you with us, especially as an early career researcher working in this field. In a field actually that does provide the support for the scientists. So how do you think, or what do you think are the most important changes or support needed to make data management and open sharing a more natural part of research in daily practices? And this is also a question you wanted to ask other early career researchers in our network. So please quickly scan this QR code, our dear participants, to answer a similar question. And we go back to Reni to present her last answer to our question. Thanks.
Yeah, thank you, Ferry. So actually, I want to be honest about the tension many of us face as early career researchers. Like many previous speakers also have covered. I know open science is important. I see its value for research quality, reproducibility, and impact. But when I am evaluated, my H index matters more than my data impact factor. My publication count is scrutinized. My data set citation are not, and my funding depends on novel findings, not necessarily on reproducible, well-documented research. So this is the paradox of the early career researchers, and especially in the global south with the not mature RDM or open science implementations. So we're told to do open science, but we are evaluated on traditional metrics. We are asked to share data, but sharing takes time, time away from writing the next paper needed for promotions. So the real question isn't just how do we make data sharing natural, it's how do we make it rational from a career perspective. And the answer is we need structural changes in how science is evaluated and supported. And it's also have been covered by Moumita on reforming research assessment. Then let me outline 4 key changes I believe are critical. So the first of all, in supporting the changes, we need to redefine what counts as research output in our evaluation system. This needs to change at the policy level and the practice level, like a journal and also other non-traditional research outputs, funding agencies, citation counts or metrics, and promotions. So this is not altruism, it's making open science strategies align with career incentives. Second, stop treating data management as an add-on task. Build it into standard workflows. This is where data librarians and interprofessional teams becomes crucial, like research supporting staff. So right now, if a researcher at university in Indonesia or other regions want to share data, the workflow looks like, okay, we finish analysis, write paper, and then they somehow realize, oh wait, I should share data. They try to figure out how, and at the end, it might not happen. Instead, imagine a different workflow built into every research lifecycle from the start of the project, during research and preservations. So this is not more work to do. It's a distributed work done at the right moment by the right person. Third, make every data and open science actors visible as career paths and partners. And lastly, we need to build regional communities of practice that support each other. Open science cannot succeed if we are isolated. We need Asia Pacific solidarity on this through RDA, EVA, and other networks. We should share lessons learned, create peer support, and advocate collectively with our stakeholders. Also, we need to celebrate our early adopters visibly so others see that it's possible. And the UNESCO webinar series we're part of right now, this is exactly that infrastructure. It creates conversation across border, reducing isolation. So let me pose the questions now because I think it's where many of you sit. And I'm curious for those of you who believe in open science but are worried about career impact, what practical steps would actually help? Is it recognition? Is it peer pressure? Knowing others are doing it? Is it institutional mandate? And for researchers in applied fields, whose research is deeply tied to local communities and local funding. So how do we practice open science while respecting local data sovereignty and ensuring benefits stay local? I think these aren't theoretical questions, they are real, and your answer will shape what we prioritize in training, in infrastructure, and in advocacy. Thank you.
Terima kasih banyak, Reni. It was really nice to hear your inputs. Thank you so much. Thanks everyone for staying with us extra minutes. Reni, you also have a question in the chat. Does 5,000 to 7,000 active ISSN titles annually mean every year's increasing? I think so, but I leave it to you to answer maybe in the chat that everyone can see. And with this, I wanted to share the inputs of the participants in our last session, but we won't have time for this, so we will merge it with your inputs of this session, and hopefully next time we will have enough time to share. With this, I would like to thank all our panelists very much for their very interesting, comprehensive, eye-opening inputs, especially the addresses to the status in our region. And I would like to invite you all to participate in our next session. We plan to have these sessions every month on the last Thursday of the month. We won't have it in December because everyone will be on leave. And the next session will be on 22nd of January, 2026. with the title Measuring and Maximizing the Impact of Open Science. Same time. I would like to also invite you, if you find these discussions useful, please spread the word, invite the relevant people in your network, from researchers, policymakers, managers of scientific institutes, universities, and those who provide all the services and support for scientists to participate in these discussions. Please tell us via this email, pcb.jakarta@unesco.org. What else do you need to know about open science? Tell us who can contribute, or if you can contribute as a speaker. And please participate in giving the inputs through the sessions, before the sessions, and we will also send some surveys later, midterm of this webinars, and at the end to really let you evaluate us and tell us how useful this has been and if it had any impact. Thank you so much for participating in this. This webpage, the QR code, will have all the information about our past and next sessions. The recordings will be shared there. Thank you all. Wishing you a very nice end of the year, and see you all in this series next year. Thank you so much.